Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 18, 2025, just yesterday. This paper introduces Depth Any Panoramas, a panoramic metric depth foundation model that generalizes while zero-shot across indoor and outdoor scenes by scaling to over 2 million panoramas and carefully curating pseudo-labels to reduce domain gaps. The paper is titled Depth Any Panoramas, a foundation model for panoramic depth estimation. Okay, and as we will see later, the geometry and sharpness-focused training tricks make the depth predictions look unusually stable across very different distances. Figure 1 shows that the model produces stable metric depth across very different panoramas, which matters because panoramic scenes swing from tight indoor rooms to huge outdoor vistas. The top rows pair each panorama with its colored depth map, where warmer colors indicate nearer surfaces and cooler colors indicate farther regions. The radar chart on the right summarizes the trade-offs, and it highlights stronger scalability and real-world outdoor performance alongside larger panoramic data volume. Table 1 makes the core bet pretty concrete because it shows that the biggest gain comes from scaling and diversifying training data. The full table lays out methods versus metric ability, dataset type, and total sample counts. The right side then breaks coverage into indoor versus outdoor and synthetic versus real world, where Depth Any Panoramas reaches about 2 million panoramas with heavy real world and outdoor representation. Figure 2 explains how the team turns a huge pile of unlabeled panoramas into trustworthy depth supervision, so the final model generalizes across indoor and outdoor scenes. The full diagram lays out a 3-stage pipeline, where pseudo-labels are automatically generated depth maps for images that never had ground truth. The left side trains a scene invariant labeler on synthetic indoor and outdoor data. The middle uses a discriminator, meaning a quality judge network, to filter high-confidence pseudo-labels. The right side then trains the final Depth Any Panoramas model on all labeled and selected pseudo-labeled data, which is where the scale really kicks in. Figure 3 explains how the model turns a single panorama into a distance in meters map, while staying stable across tiny rooms and huge outdoor scenes. The full diagram shows the panorama flowing through a Dyno V3 large-style backbone, then splitting into a range mask head and a metric depth head so distance control becomes explicit. The range mask is a learned filter that marks which pixels fall within a chosen distance limit. The bottom row adds geometry and sharpness losses, and a distortion map reweights pixels because equirectangular panoramas stretch near the poles. Table 3 is the punchline for zero-shot generalization because it shows the method winning across both indoor and outdoor benchmarks without any fine-tuning. The full table compares several baselines on Stanford 2D 3D, Matterport 3D, and Deep 360 using absolute relative error and root mean squared error, where lower is better, plus delta 1 accuracy, where higher is better. The bottom metric block shows the method taking the best overall numbers on all three datasets. Table 5 shows which design choices actually cause the accuracy gains, and it makes the story pretty clean. This table summarizes an ablation study, which means the authors remove one component at a time to measure its contribution. The left columns toggle the distortion map, geometry loss, and sharpness loss. The bottom row, where all three are enabled, gives the best errors on Stanford 2D 3D and the best accuracy on Deep 360. Alright, 2 takeaways stand out. First, the work shows that panoramic depth gets much more reliable when you scale and diversify the training data, then curate pseudo-labels so the supervision stays trustworthy across domains. Second, the geometry and sharpness-driven objectives, plus explicit distance range masking, help keep metric depth stable from indoor rooms to outdoor vistas. Thanks for listening. That is it for this episode of the AI Research Roundup. I am Alex.